All right.
Yeah. So today I want to actually bring up, let me start sharing. Share screen. There. Okay. So after the new year started, we've been focusing on getting the demo out, and I want to start by going back and taking a look at our priorities right now. So the first milestone that we had planned for was the demo, then API review. Once we get the API review accepted, the API accepted after the review, we would aim for alpha. So today I'm mostly going to be talking about the demo milestone.
Hey, I think you should get the API review start early because the deadline for the CAP merge is February 9th.
I see. Okay.
You should actually update the CAP and do the production readiness review.
Got it. So we need to make the API proposal in the CAP itself, right?
No, the CAP. I think the CAP you. So just update whatever you need to update, and then you need to add a section for the production readiness. I think last time, you didn't fill that out, right? Last time, I think we talked about that. So this time you need to fill that out, and then then pin someone on the production readiness channel to review it, and then also pin the API reviewer to start reviewing, I think.
Got it. Okay, makes sense, because we do have consensus on how the API should look. So I guess we can get started soon. Jeff is not here today, but Jeff was taking care of changes to the CAP. I'll follow up with him. And Srini here also. Srini, if you're taking notes, this is an important thing, I think.
I am taking notes. So Saad mentioned some new process. Should we follow that for alpha releases too? I have that question.
So yeah, there's a couple of things in the new process. One is the production review. Production review is not required until later stages, so it's not required for alpha. So you should be fine there. Second,
are there also something that you need to fill out for even for alpha? I thought maybe not a lot.
Yeah, maybe there's something small, but I think like the official review process, or like it's a lot less. It's not a huge deal. I think as long as you follow the new CAP template for alpha, you should be fine. I think the big change this cycle was that you need to get a production reviewer to sign off on your CAP. And that review, as far as I understand, only happens, I think, either at beta or GA stage. It doesn't happen at alpha stage. So I don't think you need to get a sign off from a production reviewer. Like Xing said, you might still have questions that you need to answer in the CAP, but I don't believe that you need to get a sign off from a production reviewer. The second big change was around just what was it? How you report that this feature is going to be part of the 121 release. It used to be that if you created a CAP issue, enhancement issue, that the release team would reach out to you on the enhancement issue and say, "Oh, should this be part of 121?" Instead, they're waiting for folks to reach out to them and tell them that this should be part of the 121 release. And so you just need to make sure that this CAP is reported in that spreadsheet that I linked to in the previous meeting.
Sounds good.
Okay. And Srini, do you know who to reach out to?
At this point, I heard only Saad, Xing, Michelle should be able to add to that spreadsheet.
Right? We already added. I added you already.
Sounds good then.
But the CAP, it needs to update. The CAP link right now is the old one.
Yeah.
Okay. So once you update the CAP link, who do we reach out to? One of you, Xing, Saad, or Michelle?
No, it's already added to the spreadsheet.
Okay. Yeah, I think you also need to have an API reviewer, right? So Saad, maybe you want to comment on that. So I think, do they just need to add the?
I think there is a label that needs to be added. Yeah, that says we need an API review for this.
I see. Okay.
And yeah, just look at there's I think a set of commands. I forget what it might be, but basically you put one of those slash commands as a comment and it should add that label.
Got it. Okay.
And if not, just reach out to me or Shing and we can help with that. Okay.
Sounds good. So yeah, there are some questions about API that we want to get clarified today. And if everything looks good, we can go get the API review process started today itself. All right. So for the demo, we set our own requirements to be. We want to show. We want to show a demo, but when we show it, it's not going to be a smoke and mirrors type of demo. It's actually going to be what we have fully working at that point in time. And the requirements we specified were we would create a bucket, grant access to that bucket. That is, we'll mint a credential for it, and we will provision that bucket into a pod. So this is what we had set as the demo milestone. Along with that, we said it's going to be done in such a way that if anyone wants to get started with it, you would have deployment files set up in a proper manner. There would be testing that would have been performed on the entire code base, and there would be documentation for people to follow and understand what's going on. And when I say testing and documentation, I don't mean full-fledged 100% coverage of testing or detailed documentation, but getting started documentation, case documentation and testing, important for the most important code flows, unit tests, and CI and E2E tests for the full stack deployment. So I want to talk about development first, and then we'll go into the other three parts here. In terms of development, this last week, we have been putting together the three components and testing them out. And we actually have create bucket working. However, even though it is working, we did reach a point where we had to clarify a little bit about the API. So I'm going to get into it now. So this is a slide copied from the meeting on December 3rd. And this reflects the result of the discussion we had about how protocol defined here and parameters defined here would be in the API. So our conclusion after that meeting was the protocol field would be, okay, so this structure is wrong actually. There should be an S3 substructure under which these three would come. Anyways, this would be a typed field, a strongly typed field, and versioned along with the bucket class itself. And because this would serve as the contents of bucket.yaml, which is mounted into the pod, and thereby becoming the API between Cozy and the application. Now, this decision to have this as a structured field or strongly typed structure here allows us to strictly control the evolution of this API and prevent different vendors or different implementations of a particular protocol from adding their own fields and kind of S3 stops being S3 at that point because everyone adds their own field if we allowed that. So the workflow in this kind of structure would be there would be a bucket class created by the admin with the necessary parameters filled in inside of the protocol. And there would be another parameters field, which is for driver specific parameters. And the bucket request will reference that bucket class when the bucket request is created by the user. And the controller would go ahead, read these two, and come up with a bucket object. So here's where the question is. and we didn't discuss this last time. In the gRPC spec for provisioner create bucket, the request currently has a bucket name, a bucket context, and an anonymous access mode. So bucket context, we originally said would include the fields that are needed to provision the bucket. And we had defined it as a map string. So my first question is, given that we've created a strongly typed field for in the API, should this also be a strongly typed field here?
Which field are you talking about?
Bucket context.
Bucket context. Where is it on in the bucket class?
So this includes the contents of the protocol.
Okay.
It is the gRPC API, so we could get away with it being map string.
Yeah, I think this goes back to that question of how we wanted to treat protocol, right?
Right.
And it sounds like we agreed protocol should be first class fields. And if we go down that path, then on the gRPC side, I think it would also make sense for it to be a first class field as well.
Exactly. Yeah, that's what I was hoping we would end up with, and that way we can actually, on the wire it can still be a map string. However, on the driver's side, they should just they should be working with structured protocol objects.
And maybe you can introduce protocol as a first class field on the gRPC side as well.
And we would have to keep them in sync, the API and gRPC.
Yep.
Yeah. Okay. So yeah, so that's good then. It's good that we're going through a very careful process of adding anything to API or gRPC then, because they have to be kept in sync. All right, so that answers one question. There's another question we have.
Well, I have a question about the mechanism by which they stay in sync. If we decide to add a new field, we have to add it to one side first. Would we add it to the gRPC first and then the Kubernetes API and default it to blank until the Kubernetes API had a value, or do it the other way around?
We'd have to add it to gRPC first, but you can't just add it. It has to be added in a backward compatible manner.
So you add it in such a way that it's optional and can be blank.
Yeah.
So that older clients will just omit it, and older plugins will, or newer plugins will just see empty values. Okay.
And then
so if it's added in a backwards compatible way, do they have to be strictly the same? Because it sounds like that's your escape hatches. You can have more things at the gRPC layer than you have at the Kubernetes layer.
I mean, what's the point?
Layer is a subset.
In terms of just managing the releases and the evolution of this entire thing, I think it's kind of a best practice, though technically we don't have to.
Yeah, I think that's well put.
Yeah. Okay.
So what happens to the additional fields that we want to?
Good question. That was my second question. So if protocol is going to be a typed field like this, we can still keep the bucket context around, have it be a map string, and use that to pass in the driver specific options.
So what is bucket context here? Why do we need it? Why is it different from parameters?
It's not different from parameters. It's the same as parameters.
Okay.
Yeah.
Why is it called bucket context instead of parameters?
The best answer I have for you is, that's just how it evolved. It needs to be fixed.
Okay. Yeah, if we call it parameters, that seems perfectly rational. I think that's exactly what we would do on the create volume side for CSI, so that makes sense.
Perfect. Okay. So in that case, can we all agree that, I mean, I think we already have an agreement on this. Protocol is going to be a strongly typed field, and it's going to exactly reflect the protocol structure in the API. And parameters will be a map string, which would be a reflection of the parameters field in the bucket class.
Yep, as long as we rename that bucket context parameter. Yep, agreed.
Got it. Okay, perfect. So Srini, does this resolve all the questions we had yesterday? We were talking about
Yeah,
yesterday.
absolutely. Yeah. So we do have to change the cap to reflect the API as well as gRPC. That's all.
Okay. Okay. Yeah. Srini, could you, if you have some time, could you add issues for this? Because I don't want to miss these.
I'll do that right away. Yeah.
Perfect. Thank you. All right. So this is resolved. So we are on track in terms of development. Now that this is resolved, we should be able to, I've been pretty aggressive about the deadlines for the demo. Having aggressive deadlines has helped us move forward quite a bit. We ran into this issue now. So we'll aim to do the demo next Thursday. However, I wouldn't consider that a very hard deadline. I would say within the next 2 weeks, if not next week, we should be able to do the demo the week after that, and satisfying all of the constraints we placed. So that would be a good milestone. All right, so development is still in progress. Let's get into deployment. We have added customized files to each of the repositories. So to deploy the entire stack, you can use these 4 commands: kubectl create -k, k for customize, and you would give the entire path of the repository. So github.com/kubernetes6/ the name of the repository. So this simple bash script will install the full stack. That's how we've been testing. That's how we've been using it. We've ironed out issues with the RBAC rules, namespaces, service account tokens, and just a whole bunch of things. And right now, these 4 commands give you the entire stack already. It's just the stack doesn't include the API changes that we discussed today. So I encourage everyone here who've been waiting to try it out to go ahead and try this out and add issues, give us feedback, start conversations on the Slack channel. Everything is welcome because we want feedback on this.
And to put this into perspective, once this gets to beta GA, the CRDs and controllers should be pre-installed by distributors, like GKE and Azure and Amazon. And then the sidecars and node adapter would come from the storage vendor.
Well, node adapter also would be pre-installed.
Oh, okay. Yep, that makes sense. You're right. Yep. So only the sidecar and the driver itself.
Yeah.
Okay, cool.
Yeah. So that's where we are in terms of deployment. So next is testing. So I know Krish is here. I know Srini is here. Is Rob also here? Rob?
Yep.
Hey, so I'll start with Srini. He's been doing most of the work on the controller. So I haven't followed, I haven't gone through all the unit tests or CI progress that's happened on the project. So Srini, could you give us an update on where we are in terms of the 3 kinds of tests?
Sure. So the unit tests are working. There are unit tests for both bucket and bucket access objects.
Okay.
I think I have enough, but not probably requires more in the future. But we made good progress on the unit test. On the CI side, we have the basic CI for make and make make tests to run on the CI side. Post submit job, there was a PR outstanding. I had made some comments. Once that is merged, then we could run the post submit properly.
What is the post submit? Is that the end-to-end test?
No, that just does the image build and push to the
Okay.
yeah, that part. But from the ETE test, I have code ready, but I haven't issued a PR yet.
Okay.
That will be a very basic. It does not have many ETE tests in it, but it will help us start writing ETE tests. We haven't made much work progress on the ETE tests yet.
I see. Okay, what is needed to do the E2E test? Like,
the framework is in place to. So I have a basic unit ETE test that runs right now, which does practically nothing, but you still can do a Ginkgo test and it works. That's all I have.
Okay.
PR should be merged first, and then should be issued and merged first before we start writing code in there.
So when you say framework is ready, does that mean the full stack deployment happens right now?
No, it assumes that full stack deployment is done. We do not have any bootstrapping in the ETE test right now.
Okay, so
there, controller is running and that kind of stuff. But that can be done.
Okay, so it assumes that the deployment is already in place, and then are there tests already?
I have a very basic thing like create and test, that kind of stuff. So I don't have it's very preliminary. That's what I
see.
But it is, you can do Ginkgo test. It probably doesn't do much, but there is some code there, skeleton.
So you mean the command executes and
runs a small test with a little bit of setup during the before and a little bit of teardown in the after.
What about, do we need any resources from Kubernetes like CNCF in order to run the tests?
Right now, that's why I did not issue the PR. You know, one of the things that I'm using is, since we are not in the Kubernetes tree, there are few of those elements I picked up from the test directory as imports, which makes us, you know, Go modules go crazy with this because it's the code that we are pulling from the Kubernetes.
So hold on. So is that related to, so I just want to go back to that. Do we need any help from, say, Saad or Shing to set up E2E tests?
No, I don't think so.
Okay. Okay, so you're saying about the Go mods?
Yeah, because, you know, I am using some of the test ETE framework from the Kubernetes tree. That because we are outside Kubernetes tree, it does not work the same way like the ETE test for other storage components, right? So
could we
maybe need to pull in more code from Kubernetes. That's what I have right now.
What are we pulling in?
The test ETE framework.
Oh, I see. I see. Okay. Okay. When do you think we can make a PR?
My code is ready. Just yeah, we can sync up and then I can push it this week. So.
Okay. Do you think we could make a PR by next week?
Yeah. Definitely.
Oh, okay. Great. Okay. Yeah, that's good. I'm glad that's possible. So you're saying this CI, so unit tests, we have a good start, you're saying, for the controller. And we have the CI running for the controller, correct?
Correct.
And E2E tests are in progress. So do we have the CI for the rest of the projects?
We do have CI for the rest of the projects, except the post-submit jobs are not hooked up correctly yet.
Okay. And what do we need for the post-submit jobs?
It's just the cloud build.yaml. We need to, yeah, we have a PR outstanding, and once we have that PR, some of the comments addressed on that,
Okay.
we should be able to. It's very simple.
Who
We are just
made the
following
PR?
whatever CSI is following, so it's not
Okay.
rocket science.
So who made the PR?
Manjunath, he's new
Oh, okay.
contributor to the project, so
Okay. Is Manjunath on the call right now?
I hope. No, it's
Okay.
too late for him.
I see. Okay. Yeah, let's follow up with him and get that added. Okay. So next, Rob, where are we on these three kinds of tests? I guess you don't have to answer about the E2E test because I think Srini's working on that.
Yeah. So we don't have any E2E tests, obviously unique to Sidecar, but Sidecar has got a pretty decent set of unit tests that I add to it anyway whenever I find an issue. So we've got certainly a test for adding and deleting buckets for all three of the different protocols and a couple of different variations like setting parameters and things. And those should be being run, I believe, as part of the builds, as part of acceptance for a PR.
Okay. Yeah, if it's a unit test, a standard Go unit test, I think that should be the case.
Yep.
We can verify that anyways.
Yeah, I'm pretty sure that they're being run.
Okay. So okay, I was just going to ask, if we make this new API change, will it fail?
Almost assuredly, yes.
That's good then. That's what I was hoping to hear.
It should change. It should fail because we're going to have to, obviously we make the change, right? We have that client that we have in the spec that we're going to need to make sure is updated since we have to create that manually, right? So we'll need to make sure that client is updated. And then more than likely, once that is updated, the builds will fail. Right, the test will just fail because we're changing the client and the values on that client.
Oh, really? So we import the client, right? Like in the projects. Yeah. So
we import that client. We import the mock client on the. Well, actually, no. I'm sorry. No, the builds won't fail because the mock client is pretty simple.
Yeah, and also the client itself, it has a Go mod on it. Like in the sense, unless you update the version in the Go mod file, it's not going to fail, right?
Well, no, that's correct. Yeah, but once we update it and we want to use it, I expect that the builds will fail.
Okay, that's fine. Yeah, if it is the case that anytime we make a change to spec and all repositories start failing, that's not okay. But if it is controlled where it only fails if you update Go mod without updating the code, that's acceptable. We can work with that.
Yeah.
Okay, so I wanted to ask Krish the same questions actually. So Krish has been working on the CSI adapter, and I saw you made a pull request yesterday. I haven't had a chance to go through it, by the way.
Yeah, it's just a pull request that makes a few minor changes related to the bind amount and the files that we mount on the pods. In terms of testing, at this point, there's not that much testing for the CSI adapter in terms of unit tests or like CI tests. And I guess that's one thing that I'll have to spend some time working on over the next week. Okay.
So, okay. I think someone sent a message. Okay, sounds good. So, is it fair to say unit tests are in progress, or have you started on them?
I think I started on the unit tests, so I have them in one branch. So
Okay.
I would say that it's in progress, but
Okay.
There's still a bit of work that needs to be done.
Okay, so is that the only thing left on the adapter side?
For the time being, yes. I think there's still some other decisions that we need to make, which will then inform changes that will need to be made on the CSI adapter. But for now, aside from the PR that's open, there's no other outstanding changes.
Okay. So, and when you say the other changes, you mean finalizers, right?
Yeah, the finalizers and the unit tests, and yeah.
Okay. Okay, sounds good. I think I have a good idea of where we're at. So it looks like we need to make the changes to the API, add unit tests in case of the CSI adapter, and add end-to-end tests. Okay, so the final thing is documentation. So this is an effort that's already in progress. Now that we understand how to deploy and we have a mechanism to deploy things, we need a getting started guide, which clearly explains how to deploy this and what to expect when the deployment succeeds, and how to create a bucket and just the most basic workflows. Two sections of it would just be two paragraphs or two sections within a simple README file. A very simple getting started guide is required at this point. We don't have this, so the only people who know how to deploy this are people who are in this meeting right now. That needs to change. Anyone who visits the project should be able to deploy it and try it out. And in addition, so I've added issues going back to the getting started guides. I've added issues for each of the repositories to add this getting started guide. I'm hoping people from the community, anyone who is interested in getting started, if you can take up the task and fill in just this, and along with that, add a paragraph or two about how about how to create a bucket, and then what to expect when a bucket is created. That would be good. So the issues are in each of the individual repositories. Once you open up the issue, assign yourself, and that way I'll know it's being worked on. Okay, so that's where we are in terms of demo. There are a few outstanding tasks. We are in progress, and they're not the most, I would say, they're not the most complicated tasks in this whole, for this whole milestone. I think we've gotten over the big bump of getting things together, having the deployment in place, and also having all the different controllers in place. The changes that we need to make now are smaller than everything we've done so far. So we should definitely be on track. We'll give an update next week in terms of where we are in terms of development, testing, and documentation. And we should be able to do the demo right after. So, okay, we still have time. That's good. There are other things to talk about, but before we go there, does anyone have any questions? Okay, so I can get into deletion and finalizers now, but I think we've discussed a lot of topics today. I'll let everyone here decide if you want to get into deletion and finalizers right now, or do you want to punt it for Monday? And we can end the meeting early today. The only reason I say this is, I don't want to overload with information. What do you all think?
Go ahead and overload us, man.
Perfect. Okay. All right. All right. So I want to talk about finalizers. We brought this up last week, and I want to continue the discussion. So when a bucket is created, when a bucket request is created, it leads to the creation of the bucket. And then a bucket access request is created that leads to the creation of a bucket access. Now, multiple pods utilize that bucket access to provision access to that bucket for those pods. So we need to make sure that while the pods are alive, the bucket access is not, the bucket access is the representation of the access token or the service account. We need to make sure that the bucket access is not deleted while the pods are still using it. And we also talked about having an escape hatch where if an admin wants to pull the rug out from underneath from the pods, just pull the access out from underneath the pods, there should be a mechanism to do that. So those two requirements are needed. The third requirement is while any of the pods are using the bucket through the bucket access, the bucket also should not be deleted. So that's the third requirement. And there's two more tiny things to also consider. That is the bucket access request object itself, which leads to the creation of the bucket access object. The bucket access request object should not be deleted before delete is called on bucket access object. Because if that happens, if bucket access request is gone and bucket access is left, then the user has no mechanism to initiate the deletion of the bucket access. The same thing goes for buckets and bucket requests. If the user creates a bucket using the bucket request, then the bucket request should not be deleted before the bucket itself has delete called on it.
So Sid, I agree with all the requirements that you're laying out in terms of what should or shouldn't be deleted, but you don't need multiple finalizers to to achieve these ends.
Okay, let's get into that. So shall we start with the pods and bucket access?
Yeah, that's an easy one. So like, what I would do there is establish a single finalizer and call it, I don't know, bucket access protection. Because you know, for PVCs and PVCs, we have the PV protection finalizer, the PVC protection finalizer. So this would be the bucket access protection finalizer, and the idea would be that you would always put it on to new bucket accesses as soon as the controller sees them and does whatever it's going to do in response to that. And then you don't remove it until until both the object is in the deleting state and there are no pods referring to it.
Right.
And then the only other thing you need is a rule that once an access is in the deleting state, that any existing pods that we're using it may continue to use it, but no new pods can start to use it once it's in the deleting phase.
Right.
And as long as you have those two rules, then you're safe. A single finalizer will cover you.
Well, yeah, that should be enough. Now, in terms of PVCs and PV, right, there is a PV protection finalizer per PVC. So if you're mounting 4 volumes, you get 4 PV protection finalizers. In case of bucket access, there is a hook that CSI gives you, which is node unstaged volume, that we can utilize to take the finalizer out when the pod goes away. Now, when we talk about having one finalizer for, how do we know there are no more pods referring to this bucket access?
You would have a watcher on pods and enumerate them and count up how many have access. I mean, you would need to have a controller with a list of all of the pods and some index by access used by each pod that would just be continually updated as pods were created and destroyed and changed state. You'd have a controller that would be watching all of that, and it would have a consistent or an eventually consistent notion of of which pods are using each bucket access. And then the idea is, as long as no new pods can obtain access to a bucket once the user has requested to delete the bucket access, then the number of pods that are using it is monotonically decreasing and will eventually hit 0.
Yeah, isn't there still a race condition?
I don't think so, because the gate is the request to delete it. Once the request to delete it comes in, the object goes into the deleting state. No new finalizers can be added at that point. And
but
in theory,
between the time it goes into deleting and you know, let's say you've enumerated the list of pods already, and well, you go into deleting and you enumerate the list of pods. Between that window, or if delete gets or if a pod starts using this bucket access right after right before calling delete.
So I think the key is that the controller that is going to react to a pod attempting to use a bucket access has to be the same one to enforce this finalizer, so that you know, it will decide internally who wins that race, right? If
is there a problem with using multiple finalizers?
I think I can see a drawback because you have to do multiple API update, right? So that actually
but there's a very clean hook for it. That's why we were thinking this way.
I've never seen this pattern elsewhere in Kubernetes, where of like a finalizer per consumer. It's typically that there is a finalizer per controller, and then the controller enforces some invariant. And in this case, the invariant is don't let it go away until there's 0 users.
Yeah, I mean, like, yeah, no, I get where you're coming from. Currently, there are no. I also haven't come across something that's using finalizers this way. However, if we look at one, is because it's not being used right now. That by itself is not a good reason to not do it. But here, if you look at pods and PVs, each PV gets a PV protection finalizer. So each mount basically is getting a finalizer. It's just not a finalizer on the pod. Sorry, each PVC gets a PV protection finalizer.
But just one. And then if there's two pods using a PVC or 3 pods using a PVC, it's still just one finalizer on the PVC.
But if you have a pod using 4 volumes, you have 4 finalizers.
Or but only one per PVC, because the PVC is the thing that's being protected, not the pod. Right. But if a second pod uses one of those PVCs, there's no extra finalizers.
Right. So that I agree with that. Here also, that when you look at the usage pattern, it looks for a single bucket access, that is, if for a equivalent of I would say equivalent of a PV here would be 1 pod using
the bucket access is the equivalent of the PVC, because it's the thing that the pod binds to, or that the pod refers to, because it's a one-way binding from pod to bucket access, right?
So let's say we have 3 pods using it. How do we know that? I still, it goes back to that race condition. So
yeah. So here's how I would do it. You'd have the controller that reacts to pods attempting to attach to bucket accesses must deny or fail requests when the bucket access is deleting. That's the key. So
yeah. So no, that's not enough though, right? Because I could have call delete, and then when I enumerate, between that time, a new pod could have started using it.
Yeah. And so in that case, the pod wins the race, and he gets in and gains access before the delete call is recognized, and then he basically slides in under the wire, and now we have to wait for him to die too before we can really clean up that bucket access.
Okay, so you're saying we would we would have to enumerate multiple times, basically.
Yeah, you would have to. The controller would have to have a a watch on pods, and it would have to have a notion of how many pods are using each bucket access, and then every time anything changes with any pod, you have to update your notion of how many, you know, and so eventually those pods will die, and eventually the controller will notice that, and it will decrease the count for a given bucket access, and eventually that number will reach 0. And when it does, you can be sure that there really are no pods using it. And as long as the number can never increase because it's in the deleting state and no new pods can gain access to it, you can be sure that you'll eventually reach 0.
I can, yeah, that is technically correct, but it is much easier and more resource efficient to have a finalizer per pod, because the hook to inform the bucket access that the pod has stopped using it is just to remove the finalizer, and that can be done on node unstage volume.
I'm not convinced that it's more efficient, because you have to have a watcher on the pods in this controller.
Well,
you have to know, you're going to have to process every pod update event. You can't avoid that.
no, we can, right? Because when the pod dies, the node unstage volume gets called, which is local, from kubelet to the CSI driver, and the CSI driver just goes and removes the finalizer on the bucket access. It is much fewer, number of API calls to the API server.
But now you have to, like, if you have 3 pods using a bucket access, you have to remove 3 finalizers, which is 3 API calls.
Right.
What I'm saying is, if you only have 1 finalizer, you only have to make 1 API call. The key is
That's
knowing
for
when to
removing,
make it.
but you're enumerating pods, and in a system with say more than 1,000 pods, paginating. So it's definitely not more efficient in terms of I/O, or in terms of I/O, talking to the API server.
But you have a watch that's just sitting there receiving events on pods continually.
A watch also gets it doesn't just get deltas; it also does the resync
periodically. But like that's all tunable. I mean, other controllers do
but
this.
Isn't
This is a normal thing.
Instead of adding all the complexity, if I know this is a new pattern, but as of right now, between the 2 patterns, this is definitely more efficient. As of right now, the 2 options that we have.
Yeah, I dispute that it's definitely more efficient. I mean, it seems to optimize for something else than what the existing pattern optimizes for, and it's not obvious which thing is better to optimize for. I would just
fair.
I would be very nervous about deviating from a tried and true pattern.
I don't think this is it's a deviation really. It is a very clean hook, and it ensures that things always just fall in place. When a node unstage volume is called, you know that the pod is gone.
Has there been any scale testing of using potentially a lot of finalizers on an object in Kubernetes?
We've done it with some of the projects in MinIO, and there are really no, when you're at a particular scale, it's hard to tell if it's because of the finalizers, or if it's because of the too many pods, or if it's because of just the number of things that are going on. At that point, you just scale up at CD. But this in particular does not add a huge overhead. At least not in an obvious way.
Okay.
Yeah, I would maybe want to get input from, like, some API guys who would have a better sense of what scales.
I think
my inclination is to follow the existing pattern, and it is true that my proposal involves watching all of the pods, that at least any pod that could have a bucket access, and that means
also the implementation complexity is way higher.
I've read a bunch of controllers, and watching pods is not that big of a deal.
No, it's not watching pods. It's making sure that no pods are using it.
Well, no, but I mean, the code would be in the same place where you would be doing whatever work needed to be done when a pod was going to use it. So I also don't think it's a good idea to have finalizers that are touched by two different controllers. Like usually a finalizer is created by and consumed by the same controller. If you ever have a situation where like one controller is creating a finalizer and a different controller is deleting a finalizer, that seems really dangerous in terms of things getting out of sync.
Yeah, I would. So Sid, we have in the past attempted to avoid exactly what is being said there, right?
Yeah.
So we've tried to avoid splitting ownership of a finalizer.
Yeah.
Yeah, I don't. That feels bad to me for just because of like version skew.
Yeah,
and,
lots of reasons.
Yeah, version skew is a good reason, but those are all manageable. The complexity, again, we looked at it the same way. To be honest with you, Ben, yeah, we started thinking, when we started, we wanted to just have one finalizer, but the race condition is what got us here.
But there isn't a race condition if you have a watcher on the pods and you just and you rely on that ratchet from when an object goes from existing to deleting. At that moment, you can't add any new finalizers. You can't do any new things with that object. You just have to. You can only remove the finalizers, and so
well, while it is going to deleting in that momentary period, it can.
Right, but if it does, it doesn't hurt anything because it just means that one more guy got in before you slam the door, and now you have to wait for him too. It's all it means. You're never gonna have a situation where he gets in the door and you delete the object out from under him.
Yeah, so you enumerate twice basically.
Yeah, well, you'd need to have a shared mutex between the code that performs this reference counting and the code that says, can I attach a new pod to a bucket? Because you're right, there's a race that has to be resolved. But if it's all inside one controller and you have mutual exclusion, you just resolve the race with a lock, and you're done.
But that also means now the sidecar becomes stateful. Well, in the sense, actually,
it's not stateful. It just has to have a watch on pods, and it has to.
You can't have a request going to any instance of the sidecar. You have to go through one always. You have to go through the leader all the time.
But if the sidecar gets killed and restarts, he's able to reassemble all of his state of the world from talking to the Kubernetes server.
Sure. Yeah. It's not stateful in that sense, but it does hit scalability a little bit.
Well, he has to have a lot of memory resources to basically keep track of the world while he's running. But yeah, if he dies, he just reassembles that in-memory structure by executing another watch.
And pods can't utilize bucket access because how do you prevent pods from utilizing a bucket access? What does that mean in the code?
Well, if the bucket access is deleting, you just say, this is a deleting bucket access, you can't use it.
What do you mean you can't use it? Like a pod request comes in pointing to the bucket access, what you prevent the pod?
It's equivalent. You would treat it the same way as if the bucket access didn't exist. You'd say, this thing is deleting, fail, not found.
So we have talked in the past internally about not keeping the bucket access request around during a deleting state. So the bucket access request is created by the user. The BA is created by Cozy. A pod references a BAR, right? So if a user deletes the bucket access request, that goes away immediately. Then the bucket access hangs around until the pods clean up and all that stuff. And that prevents any new pods from ever using the BA.
Whatever binds the bucket access request to the bucket access has to unbind at deletion time, and so you need a finalizer for that operation. So that when they get when the bucket access request gets deleted, the controller can at least unbind the bucket access from it and then remove its finalizer, and then it's safe for the bucket access request to disappear. And then the bucket access could hang around for additional time. But yeah, I mean, all these things can race, but as long as you define what your invariants are and have controllers that enforce those invariants under a finalizer, everything's fine. And you only need one finalizer per controller per object.
I don't know how big of a hit that is. Like you said, let's talk to the API team in terms of just implementation and if code is more straightforward, it does improve reliability and there are fewer bugs. So
I mean, I think there's examples all over the CSI code where we're watching pods.
Yeah, I just want to find out if one, there are any patterns where multiple finalizers are used, and two, how that has turned out for people. So I mean, I would say my experience is like I said, at best it wasn't obviously the bottleneck, but that doesn't mean much in terms of making this decision, I would say. Because it's not like it was measured specifically, but also it kind of tells us that there is a possibility that it's not an issue. So
I'm just trying to think of all this. So in this alternative scheme where you have a finalizer per pod and you try to remove it in node unstage, like, are there situations where node unstage never gets called because something gets deleted abnormally, in which case you have a finalizer that never gets deleted, which becomes a big headache for somebody? Like the failure mode that I see with the multiple finalizers is they'll proliferate and they'll become a cleanup headache for someone if anything goes wrong, because it's much harder to, in an automatic way, go through and say, are any of these finalizers bogus, without doing the hard thing that I'm saying you should do anyways, which is just enumerate all the pods and know at any time.
Yeah, but if we followed this, cleaning up the finalizer is actually pretty simple. A simple garbage collector would just enumerate, see if any of the finalizers are pointing to a pod that doesn't exist, and take it out.
Right, but that garbage collector has to do all of the work that I'm saying we should just do as a matter of course. So if you're admitting that we need the garbage collector,
it's not in the path. It's not in the path of provisioning buckets or allowing bucket access to be used by the pods. That would be a completely separate path. It wouldn't affect usability in any way.
Yeah, well, and what I'm saying is the same thing would happen for cleanup. When you have to do this logic of looking at the pods to determine when it's safe to remove the finalizer on the regular deletion path. The deletion path isn't blocking anyone from doing anything. It's just slowing down how long it takes to delete when you want to do a delete.
I see where you're coming from. I mean, at the minimum, I think we would still need 2 finalizers. One to make sure that revoke bucket access is called in the backend in the driver, and another to make sure that bucket access request is taken out.
Yes, I mean, I could easily imagine needing 2 or 3 or 4 finalizers, but it's going to be 1 per controller, not like 1 per attachment. Yeah.
Again, like I said, I understand where you're coming from. I'll let's find out more information about it, and if it turns out that this doesn't work, having multiple finalizers per pod or a finalizer per pod on the bucket access, then we will obviously go with the other approach. Yeah. So I just want to make sure the decision is informed. That's all. Okay.
So we talked, and we're past our time, but we talked at length about bucket access. But all the other ones you mentioned, are they of the same flavor? Like buckets have this basic problem.
Well, bucket would need 1 per bucket access though, or we could do the same thing. We could do.
Yeah, I'm proposing the same kind of scheme.
Yeah,
in every case, you could get away with 1, I think.
Finalizers also. You don't need to make the access calls. You just know that someone's using it when the finalizer is there. Again, we'll have to measure probably the difference.
But the thing is, you don't know. You assume that they are.
No, I'm saying we have to measure.
Could be wrong.
No, I'm saying we can measure. It's possible to measure it.
Yeah, but at that point, like, the finalizer having multiple finalizers didn't buy you anything if you have to go check and see if they're accurate. Right?
I mean, we can do a test and see if this is doable. Again, it's all coming from the point of view that code is more elegant, the method is simpler, and if the performance hit is not there, or if it's if it's very close in terms of performance, I personally prefer having multiple finalizers. If the only concern is performance, I do agree that version skew is a problem. So yeah, I'm not discounting that. But I think we run out of time, and we should continue the discussion about that also. It's manageable.
Okay.
Version skew.
That's fine.
Yeah.
Hey, so next Monday is a holiday for I think US many companies. So I don't know if you guys are, because
MLK Day.
it's a time off for me. So
Okay.
you want to continue the meeting, or you want to cancel?
I'll leave it up to everyone here. What is on Monday?
It's MLK Day.
Oh no, then it should be a day off.
Yeah. Okay. So
yeah, let's just meet on Thursday.
Maybe just to cancel it then.
Yeah.
Okay. All right. So you are going to cancel. Is that you're going to send a cancellation, right? I don't know who is it.
I think only Saad can.
Okay. I'll ping him too. But okay. I'm going to remove that from the SIG calendar.
Okay. Thank you.
All right.
Yeah.
All right.
Thank you, everyone. So, Shing, quick question. I don't know where you work.
VMware.
Oh, VMware. Oh, okay. Got it. I didn't know. I was just curious.
Okay.
Yeah. All right. Thank you, everyone. Let's talk again next Thursday.
Thanks.